Hello everyone, welcome back to yet another episode of Loc Data. My name is Sachin and in this video we are going to talk about teachable machines. So without wasting so much time, let's get started. Okay, so this is the repo I have created, Teachable Machine, and the link of this will be provided into the description box. You can check it out. And now let's go to this particular website which is called as Teachable Machine. And let me give you a brief about it. So suppose if you want to distinguish between any of the two or three or more than three objects. So like suppose I have this bottle and I want to be distinguished with this particular eye drop. So suppose if I have the images of this eye drop and this bottle, so I can create a machine learning model or deep learning model which can basically distinguish between these two images. So teachable machine comes handy with this feature. So you can use this teachable machine website to get your model without any coding. So let's go ahead and see the demo of this. So just go to this particular website and click on get started. Okay, then like which kind of project we want, image project, audio project or pose project. So let's go ahead with image project and this will say something, so just click on this. Okay, cool. Now I'm going to use this particular charger, that is MacBook Pro charger, and this is a mobile stand, we can say. So I'm going to use these two things for our demo purpose, and let's go and open the webcam. Okay, now it has opened the webcam. Now what I have to do, like first of all I need to label this class. So let's label it as MacBook charger, or let me iPhone charger. Let me rename it as iPhone charger. Basically whatever name you want you can give it as. So iPhone charger, it's fine. And the second class I will name it as mobile stand. That's fine. Now what we have to do, we just need to click on this hold to record, and we have to put the charger on the screen so that it can take the pictures to train our model. So let's do that. I'm going to hold this particular button and I will take the picture of this. So let's start. Okay, so as you can see it is taking different pictures. Okay, that's enough. So it has collected almost 202 images samples. Okay, that's awesome. Now let's go ahead and give the input as this mobile stand. Now I'll click on hold to record and I'll show this image. And make sure you give the different and angles. Okay, so it has collected 213 images. If you go ahead and click on hold to record, it will take more images, but for the timing I just wanted this many. So now it is saying train your model. So I will go ahead and click on train model, and now see the magic. It has basically started training. The whole training is happening on their server, and they will basically create a model.h5 file, or if you are guys familiar with the model training, So okay, the training has started, and let's wait for a couple of seconds or minutes. And finally, as you can see here, we can export our model once the training is done. So let's wait for it. Cool. Now as you can see, our training is completed, and if we want to check the output, we can check it over here. So let's suppose if I place this, say it's detecting iPhone charger. Now let me put this. Oh, it's simply saying mobile stand with 100% of confidence interval or probability. Now what happened if I put all those two images together? So see, our model is now confused and it is not able to distinguish. So now let me move quickly. Now see, the maximum frame is taken by this charger, so it is saying iPhone charger. And if I separate it out, then it's saying mobile stand, because now the majority of the portion is taken by this particular mobile stand. So I hope this is very useful, guys. So this means, if you are not from data science domain and you want your model to be trained for image classification, you can use this teachable machine. Now let's suppose if you have some use case that you want to quickly build your model. Okay, so what you can do, you can go on teachable machine, you can train your model for image classification, all the those three cases which we have seen earlier. And you can modify it. Suppose if you don't have time to train the model, you can train model from here within seconds, and then you can take this model, you can export from here. As you can see, the button is here, so you can export your model from here and you can give it to any fast API, or you can export as a service, and we are going to do this in that video. So for that, let's click on export model. Okay, before that, let me switch off this and now click on export model. Okay, now if you are familiar with JavaScript, you can download this particular model, but I'm not from Java, I am from Python. So yeah, this is the TensorFlow, this is TensorFlow Lite model. This is for mobile apps. This is very handy for mobile applications, Android or different things, but I'm going to use this TensorFlow Keras model, and this is the particular code it has generated. This code will simply do the predictions. So I'm going to click on save model, I will click on download my model, and it is converting my model. So let's wait for it. Now go ahead and download it in whatever folder you want. So I will download it into the desktop, and I have created one folder which is teachable, so I will download into this. Okay, so once you have downloaded your particular model, so it will basically give you two things. First one is your model, and the second one is your label.txt. So I have created this particular folder, prediction service, in which I have downloaded my model, which is keras model.h5, and the labels.txt. And labels are nothing but whatever the label you have given over here, your iPhone charger and mobile stand. So it will basically give you a txt file. 0 is your iPhone charger and 1 is your mobile stand, and this 0 and 1 will be used for predicting your images. Now if we have this model with us, now what we can do, so I'm going to show you a very simple Streamlit app. So you can consume this model.h5 on Streamlit app to predict your services or predict your differentiate your images. So let's go ahead, and I have created app.py file over here. So if you open this, okay, so this is the code. Now from where I get this code is basically on teachable machines. When you click on save model on Keras, you are having this particular code. So I have copied this entire code over here, and let me explain you one by one. So these three lines from keras.model and from pil import images and import numpy. So I'm importing keras.model. I'm loading the model. Basically load model is the library under the keras.models. This will help me to load the model. Secondly, from pil import images, so this will help me to read the images, do the operation on images and everything. And this is numpy, I'm importing it. Apart from this, I'm importing a Streamlit application over here. So if you can see, these three lines of codes are given over here, so just I'm copy pasting from here. Okay, Now let's move ahead. So for this Streamlit, I have just given the name as deep classifier project. Whatever name you want to give, you can give it. Then this is basically self-explanatory thing. np.set printout suppress equal to true. Basically I'm doing scientific notation. I'm disabling it so that we will not get a bunch of scientific notation in our output panel. So this is what I'm doing over here. Then here I'm loading the model. So load model keras model.h5, which is the name of this model. And then yeah, this is compile equal to false, and this I'm loading into the model variable. After that I'm loading the labels as well, which is label.txt, and I'm saving it into the class names. After that, what I'm doing, I'm reshaping my data variable. So np.nd shape equal to 1. So basically this model is going to take the image of the size 224 cross 224, and this 3 is the channel, that is RGB image. So this is what I'm storing into the data variable. Now here what I'm doing, so I'm using the Streamlit library to basically upload the file. So this will create a web page through where we will get a button of choosing a file, and when we click on choose file, so it will basically open our folder structure, and through where we can choose the files to upload. After that, and I'm saving it into the uploaded file. After that, what I'm doing, I'm checking if uploaded file is not none. So if this is not none, then I'm using this image library from PIL. So image.open uploaded file, so it will basically open the image, and I will save it the image into the image variable. Then I'm resizing it because whatever the image we are uploading, their size may be any of like 20 cross 20 or 100 cross 100 or 300 cross or 500 cross 500. So the size may be vary. So, and our model is tuned to get the size as 224 cross 224. So I'm basically resizing it over here. Image ops.fit image comma size comma image.resampling. So this will do the job of resizing the image. Then after, I'm converting it into the numpy array. So image array equal to np.sArray of image. Then I'm normalizing it. So basically I'm dividing it by the maximum number of pixel 127. So this will do the normalization. You need not to worry about, guys, the whole code is generated by Teachable Machine. Over here, if you go, just I have changed this particular line. This is taking the image path from our directory, but I have created a Streamlit simple application, so that's why I'm just changing this line. Other things are all same, so you can refer this code, and if you know a little bit of programming, or if you are into the data science field, you will get it. Then after, I'm saving that normalized image array into the data of 0. And then finally I'm doing the prediction. So model.predict data index np.argmax prediction whatever, and class name equal to class name of index, and then also I'm showing the confidence score as well. And then finally I am showing st.image, those whatever the captions it has shown, like iPhone charger or mobile stand, and then also I'm showing the confidence score as well. And I'm printing this those two variables, that is class name and confidence score, so that we will get the output into the terminal as well. Okay, if you are comfortable with this, so then let's go ahead and run this particular application. So to run our Streamlit app, we first make sure that you are in proper folder. So pwd, yes, so I'm in particular folder prediction service, so I'm on the right place. Now let's go ahead and run this application. So Streamlit run app.py, let's run it. If everything is right, then it will definitely open Google Chrome. Oh yes, it started, and my Streamlit service is started. Okay, it's taking some time to load. Okay, that's fine. I can see a deep classifier project over here. Now everything is loaded, and as you can see in our code, we have created this button which is choose a file over here. So that's it is showing over here. So let's browse a file, and I'm into the prediction service, and let's select the charger first and click on open. It will take some time to predict, and ta-da, here we go. So it has predicted it as an iPhone charger, though it's not an iPhone charger, it's a MacBook charger, but I have given the label as iPhone charger. That's why it is predicting as iPhone. If you want to change this name, you can change it, not an issue. And here you can see it is showing us a confidence interval as well. So 0.99 is the confidence interval, so it is pretty much confident that this is a MacBook Pro or iPhone charger. We can call it as probability score as well. Here confidence score and probability score both are same. Now let's go ahead and choose different file. Let me check this one, which is a mobile stand. Okay, it's now see, it has predicted as mobile stand with the number 1, 0 is for charger, 1 is for mobile stand. And here it is showing the confidence interval as 0.84 or 84% accuracy, right? So why it is showing like this, because we have taken the this type of mobile stand for our to train our model, but now the image I'm giving is totally different, but still it is able to predict it. So suppose if you are taking the different pictures, so make sure you are giving those as input to train your model in a better way, and in that manner it will give you the better accuracy. But no worries, I think you got the idea. Basically, if you have any use cases like you have to train your model very fast and you don't have time, you can use this teachable machine. Now after that, what we can do, we can create a Docker file, and basically we can containerize our surveys. But this will this part, Docker part, I will cover into in another video, and make sure you comment down so that I will make the containerization part of this. If you like this video, please follow and subscribe my channel, and I will see you next time.